So before starting the demo, we would like to give the background, which was shown in the presentation before, is that this is the traditional infrastructure for maintaining this kind of infrastructure in a enterprise environment. Normally there will be multiple teams, uh, server, storage, network, security, and then each one of them will have a series of work which will go through workflow, and then each of the changes first will be proposed, will go through a cab, and then finally the jobs will be performed by a set of engineers consulting with the SOP, the standard operating procedures which are there. But in this, there is no guarantee that the SOPs are maintained properly by the people who are executing it, and normally they are detected. The deviation from the SOPs are detected during an audit process. And all this process and these workflows are necessary in an enterprise environment to ensure the stability. However, that comes at the cost of agility. Now, when you do a migration from this infrastructure to AWS or any other cloud, the components, all the component becomes software virtual. However, testing process and the team structure, the workflow which was there before, still continues, and then that actually becomes a hurdle for achieving the speed that a cloud or software-defined infrastructure can offer. And when you do the steps in the cloud for creating the infrastructure, you see they are not minor. Just to create that infrastructure itself, there are 14 steps which has to be done by different teams, possibly, or even if it is a single team, there are a lot of consideration and configurations which are required. And if that infrastructure is demolished for some purpose, one has to again refer to the SOP documents and then create it, and there are high chances of mistakes. So from there we suggested that come out from the GUI, use the API, code this infrastructure configuration in form of Ansibles like this. If you are creating a PPC, then define their IP address, their the PPC name, and so on and so forth. Go on and then create the security groups like this, that what are the ports which you want to open. Then go create the key pair, and finally then name the instances that you want to launch, EC2 instances, the type of instances, what is their size, from which image you want to launch them, and then assign the key, the security group, and the network which you have created before. Now and then finally, of course, add them behind the load balancer. That was the presentation. Now once this code is there, that code will normally be in that code will be in a source management system. Here we are using GitLab, and you can see that this guy is the user one. He has one project here. This is his project, and it's the same code which we have shown in the PPT. It's the same lines of definition in YML which we have shown in the PPT. Now, benefit of maintaining this source in the source management system is that this remains a single point of truth for that entire infrastructure. Anybody, his team member, will be able to view what configuration is required to run that infrastructure, and what is the currently running infrastructure, what is the history behind it. All of them he can do. For example, if you have to see the history behind it, I can go back to the history. For example, this one, if I just go to history, I will be able to see that how different users have made changes in this infrastructure. Now let's say the workflow which we described in the PPT, there are multiple groups, and then you want to delegate that the security portion user 3 can change, or let's say the compute portion, the compute name can is determined by user 3, and he's the overall maintainer. So in order to do that, user 3 becomes a member, and he assigns on this particular uh, repository, we call it, we assign user 3 as the developer at the project. So what happens that this guy is the maintainer and he becomes a developer for this project. Fine. Now let me go and log in as user 3. And user 3 as he goes here and sees that he has no personal project. However, if he is exploring the project, he can see that yes, there is on user 1 who has a project on which he want to access, and here his role is developer. So he opens that project and creates a copy of this. Creating a copy of this project is called fork in Git, that you know. So it's getting copied here. So there will be one master copy which is maintained by the maintainer, and all of the team member will create a copy of this. And then on these, his intention is to change something. How to make some changes here? What is the change you want to make? You want to make, let's say, the instance name you want to change. We'll edit from here as user 3 and change the name of the instance. List of load balancer. Yeah. So this is new. He has changed the name of this. This is new. This is also his changing new. Let's see. And then he commit these changes, giving a commit message that changing done. Then he commit this. The moment it gets committed in the source management system, the magic starts. So after making this change, he creates a merge request. He, as a developer, creates a request that his code to merge from user 3 to the user 1. So user 3 is sending a request to user 1 to accept his code. Send it to user 1, request him to merge this code. So now I've switched and logged it as user 1, and I can see that there is a merge request which is pending here. This merge request is pending, and he is asking me, user 3 is asking me to accept these changes into my code, but I am not sure that to merge it or not. Why? Because this is my assistance here. I'll open this code and see that there is a pipeline, and this this test and build is in progress and the deploy will be progress. So I can say that once this is successful, I can merge, or I can merge manually. So let's see what is going on here. And you see this has started, and it is starting to create the VPC in the Amazon. We log into the VPC, our console, yeah, and then go to VPC, and by this time we should be able to see that there is a VPC which got created, division 1 VPC, which was named as per our division inventory, division VPC. All this thing will gradually created one by one. At this stage we are into, you see where we are, create VPC is over, and security group is getting created, and then it is launching the instance. That is interesting. Let's go launch, see the instance getting launched. So we go there, go to EC2 dashboard, and see what's going on there. We see these are instances which were terminated before. This is the instance which the user 3 wanted to create, and it is testing, it can create it. See, the key pair is there. Let us see the security groups. Okay, we want to see load balancer. It should not be there because it has not come to that stage. See. Whereas if you have to go and see the security groups, we'll see that there is a security group SG1 and SG2. SG1 and SG2, both security groups are created. We can see that some progress have happened here, and the job has succeeded, which means all the 3 instances, and so the instances has been created. Now the instance being created, this deploy would be successful. So I can go to the merge request once more and see that this is successful. Because it is successful, now as a maintainer of the project, I have the confidence that I can merge this because all 3 are clean checked. So therefore, the whole idea is that when all the workflow which are happening manually today, you can bring them into this pipeline, and so they are automatically executed through infrastructure as a code, and then maintainer will be able to ensure that it is working properly.